Welcome once again to Physics Meal, a wonderful program that is designed to help students as far as the study of physics is concerned. Remember that this is part of Mathematics and Science Meal program. It's not just Physics Meal. We feed you with physics, we feed you with chemistry, we feed you with maths, we feed you with biology. So we give you balanced diet as far as the study of science is concerned. Don't mind me. Today we are going to continue with calculations on accelerated motion. Last time we looked at the basic points that we need to consider if we want to carry out calculations on accelerated motion. And we solved one problem. So today we're going to solve the second example and then the third example. Then we can give you a takeaway question that you have to enjoy as far as this topic is concerned. Remember, we have a variety of questions to solve, yes, because we want you to be empowered as far as calculations on accelerated motion is concerned, so that you can trample upon snails and scorpions that are on accelerated motion, and no question on accelerated motion shall by any means harm you. All right, we have a question on the board, and a very simple one. We are still going to apply the principles that we used in the first example. There is need for you to watch the first video in case you missed it, so that you'll be able to follow what we are about to do on this question. Okay, subscribe to our YouTube channel and follow us on Facebook. Let's get down to business. All right, a train with an initial velocity of 20 meters per second is subjected to uniform deceleration of 2 meters per second. Calculate the time required to bring the train to complete halt. Now, the question is a very simple one. There is a principle that we introduced in our last class, and that's the IC principle. The IC principle. You still remember what we mean by IC? Identify. We say we need to identify, we need to set up, we need to explore, and then we need to do what? Execute. That's the principle we are going to use to solve the problem. So let's begin with identification and setting up. Identification means to find out the quantities given to us in the equation, and then we set it up using the appropriate symbols. And then before we talk about exploration. So let's identify and set up. A train with initial velocity of 20 meters per second. Okay, we have identified this. The symbol is U, 20 meters per second. Is subjected to uniform deceleration of this. So A, remember we said that when we are dealing with deceleration, we are going to assign a negative value to the A term in the equation. So when we get to the equation, we are going to do that. So 2 meters per second squared. They say calculate the time taken or required to bring the train to complete halt. Calculate the time. We are looking for time. To complete halt, that means to bring it to rest, to stop it. So and we say that when a body comes to rest, the final velocity is what? 0. So don't neglect this statement. So we are going to have that V is equal to 0 meter per second. All right. We have identified and we have set up. The next thing for us to do is just to explore. Remember our equation, V is equal to U plus AT, X is equal to U plus V bracket T divided by 2, X is UT plus AT squared over 2, and V squared is U squared plus 2AX. Alright? So, we have this. Now we cannot use this because no information was given about X. I didn't want to go straight to the suitable one. Let's see why we cannot use the rest. We can't use this. There is no X in the equation. There is no X in the equation. So 1, 2, 3 are off because we don't have X. So let's check this. V, we know V to be 0. And we know why V is 0. When a body comes to rest, the final velocity is 0. Then we know U, given. We know A, and then we are looking for T. So the suitable expression or formula or equation will be this. Now, because we are dealing with deceleration, we say that this will carry a negative sign. That's what we say. So negative A. So if we now translate this, this will be U plus negative AT. That means V is equal to U minus AT. That's what we are going to use. So let's now substitute and solve. What is V? 0. What is U? 20. And then minus A is what? 2T. So we can actually solve this. If I push 20 here, I'm going to have minus 20 is equal to minus 2T. Then if I divide both sides by minus 2T, because this is 0 minus 20 anyway. Okay, let's put that down. Then we have minus 20 plus minus 2T. Dividing both sides by minus 2. Minus 2 dividing this will give me 10, and this is T. So my T becomes 10 seconds. Plain and simple. So you see, I believe that the explanation is very clear. We're going to look at another question, but that will be in our next episode. We'll solve example 3. Thank you for following us. Just hit the subscribe button and also like our page on Facebook, and God will continue to bless you. Remember, do not miss any day on mathematics and science meal, because a meal a day will keep you healthy in mathematics and in sciences. I love you.